All right, hello ladies and gentlemen, this is Mrs. G. We're going to continue with our video session on solving equations. We're start to finally get to some more complicated or complex. None of this is really overly difficult, but we're starting to get to some that are a little bit more fun. Now remember, when dealing with equations, we kind of have to follow three basic rules. Those are, just to refresh your memory, everything we do to one side of the equation, we have to do exactly the same to the other. We are canceling something by doing its opposite operation, and we're always trying to isolate the variable. Okay, so now we're talking about two-step equations, and mostly I'm just going to go through example problems to show you how this works. And one of the ways that I really like to teach solving equations is to think about it like a scale or a balance. Okay, so here is your equal sign kind of divides your two sides of your scale or balance. Okay, so here we have this idea of, I don't know if that's the greatest picture, but a balance. And these two sides weigh the exact same thing. Okay, they have the same weight. And we can visualize the variable terms and the constant terms as cups and marbles. Okay, so 4x is like 4 cups of some sort of quantity of marbles. Then we have 9 marbles, 5, 6, 7, 8, 9, and then over here we just have 25 marbles. Okay, that's going to take me a long time to draw. Let's pretend there's 25 there. And so basically, if you want to figure out how many marbles are in each cup, think about it like this metaphor of a scale or a balance. Well, you're first going to take away these 9 marbles, right? Because you also have 9 marbles you can take away over here. Okay, so on both sides, you're going to peel off 9 marbles. Well, if you don't want to draw this whole scale and you don't want to draw all the cups and marbles, the way you can kind of write that mathematically or change this into more of like an algorithm for solving equations is you're going to write a -9 on both sides. You're going to take the constant term here and start by canceling that off, okay, which is the same as this idea of cups and marbles. This is the same idea as taking away 9 marbles here and taking away 9 marbles there, okay? On this side, you're not going to take away all the marbles, so there's going to be some marbles left, and what that looks like up here, okay, is this idea of, on the left side of the equation, the +9 and the -9 cancel out. On the right side of the equation, you're actually going to do 25 minus 9, and that's going to obviously be 16, okay? Again, it's nice to do some sort of visual for where each side of the equation is. Sometimes I like to kind of just highlight it like that. Oh, nice straight line. And so now we continue kind of vertically working down. We've canceled off our marbles from the left side. We've subtracted 9 from both sides. Here on the right side, we get 16. On the left side, all we have remaining is the 4x. So now we have 4x equals 16. We only have one more step to finish solving this equation, and that's to divide by 4. Okay, so on both sides I divide by 4. Because what I saw was multiplication, I saw 4 times x. So on both sides I divide by 4. And what that gives me is x equals a +4. And you're done. Okay, you may have noticed, if you want to kind of make a general summary of what happened here, is generally first we move the constants together on one side of the equation. Okay, that involves an addition or subtraction. And then second, oh my goodness, sorry about that. Second, we will then multiply or divide. Okay, so very often we add or subtract first, we multiply or divide second when it comes to two-step equation. Okay, again, let's just go through some examples and I think you'll see how it all works. The second example, just be careful about your negative signs. So again, here is the line that separates the two sides of my equation. And I'm going to start by adding or subtracting. I need to subtract 11 from both sides. Okay, I need to subtract 11. Move my marbles over here to the right side of the equation. All I have remaining here is a 4x. So we have 4x for both of them. And then on the right side here, I have -17. Lastly, I divide by 4. Oh my gosh, it doesn't divide evenly. Oh my gosh, it's a fraction. That's okay. Leave it as an improper fraction. Improper fractions are just as good as mixed numbers or decimals. So you get -17 over 4. Okay, it's as easy as that. You could make that into a mixed number. You can make it into a decimal if you really wanted to, but you don't have to. Okay, let's just keep going with some examples. Okay, we might have two-step equations that look similar to these here. Just follow the same idea of adding or subtracting first, and then maybe multiplying or dividing second. Let's start with example 1. So we want to make x alone. We need to get rid of the minus 5. We need to get rid of the divide by 6. Okay, which order do we do them in? Well, first we're going to add or subtract. Move the marbles together, so I plus 5. Okay, and then these cancel. What I have remaining is x over 6 equals 13. And then my second step, again, your two-step equation, is to multiply. So I see a division. So what I need to do is multiply by 6. Okay, these cancel each other out because 6 divided by 6 makes 1. 1x is just x. And therefore, I might have to do some long multiplication here. That's okay. Write it out. 6 times 3 is 18. And 6 times 1 is 6 plus 1 makes x is 78. Okay, x is 78. Alrighty. So that's just another example to work you through this one. Your second or final step is multiplication. Now this one is an interesting one. Alright, what's happening here? Well, you still kind of have this look of a fraction going on. But what's interesting about this one is you have this entire expression that is 2x minus 7 being divided by 5. So really, in this case, I kind of threw a curveball at you, but in this case, we first need to get rid of this divide by 5. So that's actually the first thing you do. If you multiply on your equation, or I'm sorry, multiply both sides of your equation by 5, this 5 cancels with this 5 because this is really just one fraction. It's got this weird expression on the top, but you really just have one fraction multiplied by a second fraction, so these 5's cancel out to make 1 and 1. What gets brought down here is just 2x minus 7 equals, and then on this side I need to do my multiplication. 6 times 5 is 30. Okay, now this might look similar to some of the problems we did here. This is actually more like a 3-step equation, I guess, but that's okay to get a bit of an extra challenge. So now we need to move the marbles together. Start with your adding or subtracting. Add 7 to both sides. Okay, these cancel out. 2x equals 37. Divide by 2. And oh my goodness, again, we might end up with a fraction. That is okay. And this doesn't go unevenly, so I'm just going to write 37 over 2. You could write 18 and a half. You don't have to. Improper fractions are just as good as any other type as long as they're simplified. Okay, so throwing some more interesting 2- and 3-step equations at you. And if you're interested in continuing, I'm going to work through a few story problems. All right, I think you guys can try these out later on homework assignments. Or if you want, it's up to you. If you want, go ahead and try these 2 in your notes. See if you're understanding how to do it. Go ahead and click pause and try those out. All right, coming back. Hopefully you're done with those 2 problems if you're interested in trying them out. In the first one, you'll know your understanding if you got -2. All right, -2 for that one. Be careful that when you bring down this term, you bring down a -4x. And then in the second example here, the answer is +9. All right, so now, as I promised, are some story problems. If you're interested in practicing a bit of problem solving, stick with me. And we'll go through some story problems. All right, so example 1 says Joe is paid a weekly salary of $520. He's paid an additional $21 for every hour of overtime. Oh, he works. Oh, Joe could be a she, I guess. Oh, no, he works. This week, his total pay, including his regular salary and his overtime, was $604. How many hours of overtime did he work? Okay, I want us to write an equation. Okay, we're practicing translating a real life situation into an equation that I can then solve. Okay, a lot of you are probably, maybe mentally working through the process in your brain, but let's see if we can work this out or write it down as an equation so that if we're not sure of how to attack it mentally, we're building a method for how to basically translate this into an equation. So what's the basic idea? The basic idea is that he has a base salary and he also has an overtime. And in this situation, together that made $604. Okay, so we have base salary plus overtime. Okay, I like to take this idea of kind of making out a sketch kind of the situation with some words, and then starting to fill in some of the numbers in the math. So in this case, his base salary was $520 plus his overtime. Now this is where it gets interesting. Okay, it's $21 per hour. And the question is, how many hours of overtime did he work? So your variable, okay, to define your variable, you'd say X is the hours of overtime. Okay, the hours of overtime, excuse me, has to be 21. Oh, excuse me, very sorry about that. It's embarrassing. So the overtime is going to come from $21 multiplied by each hour. Okay, multiplied by each hour that he works, and that will give you 604. So this is really the fun part, folks, is taking this whole situation and visualizing it as an equation. Okay, from there, I think I'm going to leave the actual working out to you guys. Basically, you're going to minus 520, subtract 520 first, work that through, and then later on, you would have 21x equals a certain number, and divide both sides by 21. Okay, so I just wanted to practice a bit of the translating a story into an equation. Okay, you guys go ahead and continue the solving on your own. All right, and then example 2. If you're interested in how this works, maybe you want to pause it and give it a try. Okay, Chris's landscaping bill is $380. The plants cost $212, but then he also has to pay for labor, which is $48 per hour. Okay, so that happens every hour. We have to multiply 48 times the number of hours. And it says how many hours did the landscaper work. Okay, it's a really good idea to start by defining your variable like I did here. Okay, and sometimes I like to use a letter that makes sense. Maybe I'll use H. H equals hours of labor. Okay, so you have to pay for both your materials and you have to pay the people. I'm sorry, this is the materials here. That's the materials here. And then you have to pay the cost of your workers per hour to actually put the kind of, in this case, the landscaping in for you. Okay, so the total is $380, and that total comes from the basic cost of the materials, in this case it's plants, plus $48 per hour. There's where your multiplication comes in. Okay, do you see how this works? This is the materials, plants, plus the cost of the labor itself, and that equals $380. Okay, do you see how we're translating this this English situation into an equation from there? Okay, now you guys know the actual procedure to solving this. You're going to subtract 212 first. Once you do that, you'll get 48h equals, I guess I had to write this out. I could kind of borrow. This is a 7, this is a 10. 10 minus 2 is 8. 7 minus 1 is 6. So 168 divided by 48, divided by 48. I might grab my calculator for something like this, and that's perfectly fine. I'm guessing it's probably about 4, or maybe 3. I'm sorry, 3. 50 times 3 is about 150, so let's do 168 divided by 48. Is that going evenly? Oh, close. 3.5. Okay, so they spent 3.5 hours putting in Chris's landscaping. Okay, I'm going to stop the video there. I'm going to stop this little tutorial. But if you're interested in problem solving, I have a lot of extra work with problem solving. This is going to be the higher level stuff on your tests. Okay, folks? So if this is fun for you, please seek me out. If you want some more problem solving stuff, and you guys have a fabulous day. Mrs. G is out.